Hello, welcome back. My name is Wireless Maliki. In the last lesson, we said that compounds which are made up of hydrogen and carbon are known as hydrocarbons. And both hydrocarbons and their derivatives, of course, are organic compounds. Let's see here. Here we have hydrocarbons and their derivatives. For example, on the left side we have methane, CH4, and here on the right side we have trichloride methane. Now, 3 hydrogens atoms are replaced by 3 chlorine atoms. Another example, methane and methanoic acid. Here, 2 hydrogens are replaced by 2 oxygen atoms as the derivative. So this means we can define again organic chemistry as follows. But organic chemistry is a study of carbon and hydrogen containing compounds and their derivatives. A study of carbon and hydrogen containing compounds and their derivatives is known as organic chemistry. That is another definition, which is actually also true. In this video, we are focusing on the study of development of the science of organic chemistry. So we will stress here development of the science of organic chemistry. How the science of organic chemistry, of course, was and how it is now. A science of organic chemistry in 19th century. Here is where the history starts. In 19th century, there was a theory known as vitalism. A theory known as vitalism, which was heard at that time. A theory of vitalism. Of course, what does this vitalism mean? Vitalism theory postulates that organic compounds come, or we may say that are compounds which originate from living organisms. So this is the basis of this theory, a theory of vitalism. In a theory of vitalism, it defines organic compounds as those compounds that come from living organisms. So all those compounds which come from living organisms are termed as organic. This is a basis of vitalism theory. It's actually, when we say living organisms, we mean plants, animals, and so far we have all from the level of microorganisms to the macroorganisms. In vitalism theory, another point was the basis that there is a vital force in organisms, which this vital force actually make organic compounds in living organisms. So a vital force which make organic compounds in living things. That's the name itself, organic chemistry. Another point which is very important in vitalism is that manufacture of organic compound in laboratory is not possible, or you cannot manufacture organic compound in the laboratory. That was the concept of vitalism. So in vitalism, it stressed or on the fact that all organic compounds cannot be made from non-living resources. In other words, you cannot make organic compound in the laboratory. For example, you have maybe a sample A and a sample B to mix together so as to obtain a particular organic compound. This process, according to vitalism, is prohibited or cannot be done or is not possible according to vitalism. But things changes. In 1828, Friedrich Wöhler, a German scientist, made it possible to synthesize organic compound in the laboratory. So in 1828, organic compound for the first time was made in the laboratory from non-organic resources. In 1828, organic compound was made in the laboratory from non-organic resources, of course by F. Wöhler, a German scientist, the first man to make organic compounds in the laboratory. How this was possible? What he did is to evaporate ammonium cyanate, of course a solution of ammonium cyanate, aqueous solution. That way ammonium cyanate solution was heated so as to obtain organic compound known as urea. This is the formula of urea, NH2CO NH2. Ammonium cyanate, which is non-organic, to obtain urea, which is organic. So for the first time. Now, ammonium cyanate, as I have said, was heated so as to obtain urea. You see here that ammonium cyanate is non-organic resources, but urea is organic, because urea is a content in urine, which actually urine is produced in the kidney. So urea is produced in the kidney. So for the first time, F. Wöhler said or produced urea without a kidney. F. Wöhler produced the urea without a kidney. That is how he said that now I can produce urea without a kidney. Now, if we check again this reaction, that say ammonium cyanate in the presence of heat to get urea, we see that this reaction is a rearrangement reaction. Nothing new is added, but it's just a rearrangement due to the presence of heat. You see here 4 hydrogens. Yes, 4 hydrogens, 2 nitrogens on the left side and the 2 nitrogens on the right side. 4 hydrogens on the left side, of course 4 hydrogens on the right side. Carbon oxygen on the left side and the right side as well. So here ammonium cyanate to obtain urea. Ammonium cyanate is non-organic, but urea is organic. So for the first time, then vitalism, of course, was discarded, because the point that you cannot make organic compound in the laboratory, now we can make urea from the lab and also from the kidney. So this means that organic compounds can be natural, for example carbohydrates, protein, etc., or can be artificial, for example plastic. synthesize organic compounds.